It's humbling working with a guy named Dr. Patrick Soon-Shawn. If you don't know him, please go out to our website, watch him. He's a genius, kind of a Renaissance guy. I actually am working in the NantHealth division of NantWorks, and that's a compilation of about 6 companies. Patrick owns a total of 45 different companies. He's worth $9 or $10 billion. And his mission is really to change healthcare. And how does he do it with precise medicine? He's very focused on precise medicine. Little history on Patrick and what he's done in Arizona. Many of you might not know this, but he worked with Mayor Gordon, ex-Mayor Gordon, years ago to build a plant in Phoenix, to build an injectable plant. One of the most modern injectable plants in Phoenix now, Celgene owns that, and that's where they created the drug Braxine. If you know anything about Braxine, it's a great breast cancer drug and just was approved for late-stage pancreatic cancer. So that drug is pretty phenomenal. He's saving lives with that drug. So now he's looking at how does he take technology and change healthcare with technology, because he believes the cognitive problem we're going to face in healthcare is pretty significant. So I'm going to show you some of the things that we're doing today. Could you advance that? Can I advance it here? Awesome. Okay, a little background on the vision, just to cover where we're coming from here. If you look at the 3 domains, the knowledge domain, delivery domain, next generation payer domain, today those domains are very isolated. If you look at research today, research typically takes about 17 years to get a product in the clinical world. So if it's a drug like Braxine for pancreatic cancer, he's had several patients. He believes he could have probably cured jobs too with his pancreatic cancer drug. So 17 years is too long. That has to change. We have to figure out how to integrate that knowledge domain into the delivery domain. So we have to provide the right tools, the right cognitive tools that actually help our docs provide better care for our patients. The other thing is we have to integrate payers into the delivery domain. Today it's not highly integrated and they're somewhat competitive. We have to change that model. And the whole idea here is how do we provide right care at the right time for the right cost. And that's a big challenge because the way our system is set up today, it's so disaggregated and so regional by nature. So next slide. So here's kind of a little bit of the problem domain so you can get a sense of it. If you look at traditional clinical decision support, a person can make they can look at 5 to 10 different variables and make a decision based on those 5 or 10 variables. If you start looking at adding genomic analysis, diagnostics capability, proteomics, all of a sudden the variables expand to over 10,000. And it's really impossible for anybody to have the cognitive ability to actually make a clinical decision for you as a patient. It's very, very difficult. So what you have to do is essentially provide clinicians with high-performance compute, in their iPad. You have to change the way you actually deliver science and technology to these clinicians. And again, it's really about how do you provide precise medicine for patients today. Today, most of us do not get precise medicine. And I'm going to give you a personal story about where precise medicine has changed a kid's life. Next slide, please. So the way we kind of look at technology and solving this cognitive problem is you have to look at it from a delivery perspective, a patient perspective, and a medical record perspective. And we've integrated all these systems, and we're really focused on how do we transition healthcare to value-based models, outcome-based. How do we provide patients with more decision support tools and tools to help them actually manage their own healthcare and understand their own healthcare? And then how do we provide systems that integrate these disparate systems today, all the way into the payers? For example, today we have a product in about half the oncologists in the US that connect directly to payers and do pre-authorization of evidence-based medicine. And just, if you stop there a second, we can reduce the problem of arbitration between oncologists and payers. We can do pre-authorization of evidence-based medicine in real time. And that's providing big data-like solutions directly at the hands of the medical oncologist. So you know that it's no longer the Wild Wild West for oncology. They're using the best evidence-based medicine available today on the market. Now if you take that a little farther, next slide. Keep going with a couple slides. I'm going to show you a picture. One more. Okay, I'm going to tell you a little personal story. to set this up to give you the problem. So, how many of you know what cystic fibrosis is? Really tough disease, right? So in kids, typically it's a genetic disease. Male and female have to have a mutation that actually 1 in 4 kids can actually get that genetic disease. Kids have difficulty with breathing, difficulty with thrive issues. There's a lot of issues with kids that have CF, and they typically die young, especially if they don't get lung transplants. It's a very serious disease. And about 1 in 20 Caucasians actually carry that mutation. I don't know if you knew that, but it's a fairly high number. So 1 in 2,500 kids get this disease. Now I'm going to ask you a question. If you would have, I have a son with CF, and if you knew, just a few years ago, his size, could you guess which one is my kid here? Which one? So you would think that, right, with thrive issues? Actually, this 63 is my kid. He's a 16-year-old kid, starts on the offensive line. He's over 205 pounds and 6 foot tall. And I'll tell you, a couple of years ago, he wasn't that big. And this is an example of where precise medicine can change patients' lives and really keep them out of the hospital and drive down costs. There was this new drug that came out for his mutation, his specific mutation. It was designed to change the protein channel so it opens and closes properly so the ions flow over the cells, essentially so it thins the mucus. So now he doesn't have quite the pancreatic issues and not as much lung issues. And that lets him play football an entire game starting on offense. And he couldn't have done this 2 years ago. So this is an example of how precise medicine can change a patient's life. And now let me set up the whole story for you. He goes to the Phoenix Children's Hospital, great hospital. He has probably one of the best CF docs in the state. There's only 1 or 2 CF clinics in the entire state. 2 years ago, about a year and a half ago, we went into the doc and said, hey, we're excited about this new drug that's coming out. It's designed specifically for his mutation. The doctor said, no, it's not. And we said, yes, it is, because we knew his mutation. And he flips through the paperwork and he goes, wow, this is a game changer. This will change his life. And let's pause there real quick. I mean, imagine if the doctor had cognitive tools. He knew all the best evidence-based medicine for that CF patient. Here's the treatment regimens you need. Here's all the clinical trials available, and then here's the precise therapies that he needs specifically for that mutation. If he had that tool, what would have happened? It's pretty simple. He would have been on that phase 3 trial because only 4% of the CF kids have that mutation. So if he's on that phase 3 trial, you know anything about CF, that drug actually flatlines his lung function. So every year he's losing more and more lung function. He could have more lung function if he would have been on that phase 3 trial. Now it's not the doc's fault. The doc has 8 minutes with my son. Let's be honest. They pull lever and a kibble. That's what they do. They have 8 minutes. That's the way we've set up the system. We've set up the system to pay our docs that way. It's not his fault. But if we start providing cognitive tools like Patrick's doing for cancer, and tools for kids like this, where you can see all the evidence-based medicine and the clinical trials and any precise medicine like genomic analysis or proteomics to target the therapies, I'm telling you, we can change the way we take care of patients. Now, this is going to require new systems, new technologies, new people looking at this. And it's no longer just clinicians. It's data scientists, big data scientists. It's molecular scientists. It's a very different world. In fact, even when you start looking at how do you care coordinate this, our nurses are going to have to be different kinds of nurses. But I think you heard Grand Canyon talk earlier. I've been working with their nurse program, and they're going to create a computer science program. How do you create nurse clinical analytics with computer science program? Because you're going to have to look at things a lot different than we do today. And start using these simulation tools. Every other industry has done this today. If you look at making automobiles, there's a book called Innovator Prescriptions, and it talks about making automobiles safe. If you remember 15, 20 years ago, the only automobiles that were safe were BMWs and Volvos and Mercedes. Today, you can buy a car from Korea that's just as safe as any BMW is. Now, why is that? Because they have simulation tools and cognitive tools to make that engineer in Korea just as good as the engineer in Germany. Again, this is where clinical care needs to go and precise medicine needs to go. And Patrick and NantHealth are all about that. In fact, Mayor Gordon is actually working with me still today, and we're working on some big projects, and over the next 6 months or so, you're going to see some very interesting things that we're doing with Patrick in the state of Arizona around some of these technologies. Thank you very much.